In today's lesson, we will be looking at section 8.4, which is about ellipses. We'll be graphing ellipses and writing an equation of ellipses given certain conditions. This is the basic information we need about ellipses. Okay, first, the ellipse is more of an oval shape. It's a stretched out circle. Okay, it is more related to a circle than it is to a parabola. The definition of ellipse is the ellipse is a set of all points in a plane such that the sum of the distances from the foci is constant. There are two focus points in an ellipse, okay, and they're always found on what is called the major axis. Okay, this is our ellipse. This is our example of our ellipse. And these points that I am highlighting here in red are our focus points. Okay, there are two of them. Okay. If you pick any point on the parabola, let's just say this point here is measured by P, and I measure the distance from one foci, which is D1, and the distance to the other foci, which is D2. If I add those distances together, I'm going to get some number. Okay. If I take another point on the parabola, say here, and I add this distance, we'll call it D3, and then this distance from the focus to that point, we'll call it D4. If I add those distances together, it's going to be that same constant. And if I pick any other point on the ellipse and find the distances to the foci and add those two distances together, it will always equal that same constant. Every ellipse has a different constant. It's not always the same for each ellipse. Okay, the things that we need to be able to know and find out from an ellipse. I'm going to start actually at the bottom. You need to know where the center is. Okay, to be able to graph, you need to know where the center is. The center is found at the midpoint of both axes. So the axis, it has a major axis and a minor axis. The major axis is the longer of the two. The minor axis is the shorter of the two. In this particular example, the major axis is the horizontal axis. It is longer than the vertical axis, which would be the minor axis. And then we have two foci, okay, two fixed points that are always found on the major axis. All right, a lot of information on this page. First off, standard form equation of an ellipse. Okay, an ellipse is found by taking x minus a squared plus y minus k squared equals 1. So look at they're being divided by these values. An ellipse will always equal 1. Okay, always equal 1. Important points. The center is your h and k. Okay, now it is addition, it is commutative, so it doesn't matter if you start with the x minus h squared or the y minus k squared. No, it doesn't. Okay, but you'll always see us start with this in this way. A, the a value, not a squared, the a value represents how far from the center to place points to the right and to the left. How I always remember that is that a is found under the x. The x is your right and left coordinate, so it tells you how far right and left. B represents how far from the center to place points up and down, and how I remember that again is B is always under y. Y is your up and down coordinate. The major axis is always the longer axis, and the foci are found on that axis. You have two different ways to find the major axis. If it's horizontal, you find the foci by finding the C value. And what C is how far is the distance from the center the foci are found. If it's on the horizontal axis, it's a squared minus b squared, and you find the C. If it's on the vertical axis, it's b squared minus a squared. Basically, what you need to remember is we don't want a negative distance, so we want to subtract them in the order that it will keep it positive. And again, C is the distance away from the center that the foci are found. Let's see this in use. We're going to start with an ellipse that is in good standard form for us. We're going to find the center and the foci and the length of the major and minor axis. Okay, we will also graph it. We're going to do this basically all at once. Okay, we're going to first find the center. When it's already in standard form, that's a piece of cake. Center is at 2, 1. Okay, it's the h and k. We're going to place that. I would suggest graphing this at the same time as you're finding all this information. So I would place that center of 2, 1 on our graph, and I'm going to highlight it here a little bit bigger now in red. Now you're looking at your A and your B values to figure out how far right and left and how far up or down to put more points. You need 4 more points total. Okay? Because the a squared value is 4, a is equal to 2. So that means you place 2 points that are 2 units to the right and 2 units to the left of the center. Okay? Because your b squared is 9, coming from what's under the y, b is 3, which means we put a point 3 units above the center and 3 units below the center. Those 4 points should be enough to get us our ellipse. So again, we have our center, we have our points to the right and left, 2 units right and left, 3 units up and down. You create your ellipse from those 4 points. You should now also be able to visually see which one's the major and minor axis. Because we went up 3 units and down 3 units, that's a total of 6. Okay, we only went right and left 2 units, that's a total of 4. So the major axis is vertical, and it's 6 units long. The minor axis is horizontal, and it's 4 units long. What that also tells you is that the foci are found on the major axis. So the foci will be found somewhere on this axis. Okay, so what coordinate is going to change then to find the foci is going to be your y coordinate, because you're moving up and down to find those coordinates. So we need to find the c value. So we're going to take the b squared minus a squared, okay, which is really just going to be 9 minus 4, which is the square root of 5. So it says the foci are found a square root of 5 units up and down from the center. So if I have the center here at 2, 1, and I want to move up square root of 5, that would take me to 2, 1 plus square root of 5. And if I want to move down square root of 5, that would take me to 1 minus square root of 5. Those are the locations of my foci. And I can simplify that by just going ahead and writing 2, 1 plus or minus square root of 5. It includes the up and the down. I want you to hopefully notice, let me go back to this one more time, notice that we are not graphing the foci. Okay, we just need to state where they are. In this example, we're going to do the same thing, find the center, find the focus, find the length of the major minor axis, but it's not in standard form, so we have to complete the square. A lot like a circle, we want to group together our x's and group together our y's. Any constant we want to move to the right-hand side of the equation. So as I group together my x's, there they are, group together my y's, I am going to complete the squares, but there's something I need to do before that. We can't really complete the square with a 9 and a 4 leading coefficient, so we need to do some factoring. We need to factor off the 9 off both terms. Now we can complete the square with the 1. We need to factor off the 4 off both y terms. Now we can complete that square with the 1. When we compensate, though, to the right, we're adding to the left, we're going to add to the right, we're adding across the equal signs. We compensate with the 9 times the 1, so there's where the 9 came from, and the 4 times the 1, so that's where the 4 came from. So we keep simplifying. We have our x minus 1 squared now and our y minus 1 squared. Now it equals 36, but we want the ellipse equal to 1. How do we get it equal to 1? You divide everything by 36. Divide by 36. Okay, divide all sides. So that's where the 9 and the 4 go. They simplify. 9 goes into 36 4 times, 4 goes into 36 9 times, and then now it is equal to 1. From here now we can get our HK, A, and B values. Okay, so now you see our center is at 1, 1. A is 2, and B is now 3. So again, I can put points 2 to the right, 2 to the left, 3 up, 3 down. So it's very similar to our last example. Those should be enough to create our ellipse, so it's done graphing now. Major axis is again vertical, minor axis is again horizontal, and the focus again are found on the vertical axis because it is the major axis. Again, they're found square root of 5 units away. You can see the work to find your c value, and this would be the location of the foci as we add to the y and subtract, to the y coordinate in order to find those foci on the vertical axis. I would like you to try this example before class tomorrow, and we will go through this in class. We're also going to be writing equations of ellipse. Okay, so we wanted to write this equation of an ellipse with endpoints of the major axis at 0, 10, and 0, negative 10, and the endpoints of the foci are 0, 8, and 0, negative 8. What we want to do is find the location of the center, and you got to remember the definition of where the center is. The center is found at the midpoint of the major and minor axis. So if we know one of the axes, we can find the midpoint of it. We know the endpoints of the major axis. So in the midpoint between those 2 points is going to be the center. If you use the midpoint formula, the center is at 0, 0. So your H and K are 0 and 0. So you can see now the work inputting the 0, 0, and there's where we're at. Okay, what we need now is our A and B values. Well, one of them we can find very easily. Okay, because our center is at 0, 0, and then we're moving to 0, 10, and 0, negative 10 on your major axis, that is moving up and down 10 units to get to those points. Up and down is always your B, so B is 10. So we square it to find your B squared. So now we're here. All we need to do is find our A. That's where our foci come in. The foci are 8 units from the center, going up to 0, 8 and down to 0, negative 8. So we can use the C value of 8, which equals the square root of the B squared minus A squared. And we can solve now for A squared, and you can see how that's being done. And the A value is 6. And then your final equation, you always square that. It's A squared in your equation. So I'd like you to try that with this one. It's a very similar example. You want to find the equation of the ellipse with the major axis endpoints at 2, 2, and 2, negative 10, and the endpoints of the minor axis are at 0, negative 4, and 4, negative 4. That concludes our notes for today.